and eliminate one variable. Okay. Now I need to think about this and try to do the best thing for me in solving this problem. So when I look at those equations, I try to think, okay, I can eliminate either x, y, or z. It doesn't matter which one you eliminate, but we just need to pick one. And when I look at those, I look at that and I say, okay, well, the x's, I got 2, 5, and 3 in front. But on the y's, if I look at the second two equations, I got a positive y and a positive y. So that would be easy to turn into an elimination and get rid of the y's by just multiplying one of them by -1. That seems like it'd be easy to do. So that's what I'm going to do. I'm going to take an easy path here to get rid of y. So I'm going to eliminate y with that first, or with the second and the third equations. Okay. And sometimes it's helpful if you'll just number the equations so that when I talk about them, 1, 2, and 3, we're going to put 2 and 3 together and get rid of the y. So to do that, what I need to take one of those and change the signs of everything, right? That's what elimination does. We're taking -1. I'm going to take it times the second or the third equation, the second one in this pair. I'm multiplying the third equation by -1 so that I can eliminate y. Okay, Becca? Same thing. Those are the same steps. So that gets us -3x minus y plus 8z is equal to positive 28. And then the other one didn't change. 2. And so when I add those together, I get 2x plus 10z is equal to 38. So I get an equation that has two variables in it. Okay? I'm going to hang on to that one, just going to set it over there, and I need to do the next step. So the first step, pick two equations and eliminate one of the variables. Okay? Pick a variable to eliminate. The second step, so step 2, is to use a different pair of equations and eliminate the same variable. Because I chose to eliminate y in the first step, I have to eliminate y in the second step. I've got to choose to eliminate the same variable twice, but I can't use the same two equations. I've got to use two different ones, because if I use the same two, I get the same answer back, and that doesn't really help us. Okay, so we either have to use 1 and 2 or 1 and 3, and it doesn't matter which one. It's going to be the same work no matter which one we use there. So if I use number 2, that'll be, it's right there together, so that's easy to do. So I'm going to take equations number 1 and 2 and put them together. We've got 2x minus 6y plus 9z is equal to -8. And then the second equation is 5x plus y plus 2z is equal to 10. And I'm going to multiply the second one by what so that I can eliminate? Got to multiply the whole thing by 6. That's going to give me 30x plus 6y plus 12z is equal to 60. And 2x minus 6y plus 9z is equal to -8. Now I add those two together, and I get back 32x. The y's eliminate one another just like the other problem did. And then 9z and 12z is 21z, and that's equal to 52. Okay. Now, look at both of the green equations. They have the same two variables in them. So what I can do now for step 3 of this process is use the new two-variable equations to solve So we're going to take both of those equations, the 2x plus 10z is equal to 38, and then the 32x plus 21z is equal to 52. We're going to take that system, and now it's a two-variable system like we've been doing all week. And we can choose what method to solve that one with. Okay, you could use elimination, you could use substitution. It doesn't matter. Pick a way to solve that system for one of the variables. So we're gonna, if I'm gonna use elimination, I gotta choose, am I gonna eliminate x or z? I'm gonna use substitution, I gotta solve for one of those. Okay, so how could we do that system? Substitution would work. So if I solve the first one for x, I can substitute it into the second one for x, right? What if I wanted to use elimination?
You can multiply the 2x plus the top one by
negative 16, and that would get rid of the x's. That would be one way to eliminate x's. Either way is going to work fine. I'm going to do the elimination on this one because we're going to get plenty of substitution on the next few steps. Okay, so if I multiply the top one by negative 16, that gets me negative 32x minus 160z. And then I don't know my 38 times table, so I'm going to cheat here. Negative 608. And then the second equation doesn't change. And then I put those together. The x's cancel. And then we got negative 160 plus 21 is negative 139. And then 608, negative 608 plus, how much was it? 52. Negative 556. Divide. I get 4. There's our first answer. Now we've got to go back and get the rest of them. So I got z is equal to 4. Where can I go back and get one of the other variables? Can't go to the originals. It's got 3 variables. I only know one. I got to go to a 2 variable, and so that I can get the other variable there. So I want to go back to one of these green ones here and plug in the 4 for z and solve it. So I'm going back to one of these and plug it in. So 4 into z there on I'm going to go to the 2x plus 10z. So 2x plus 10 times 4 is equal to 38. That was the 2 variable problem I came up with. So that's 2x minus 40 or plus 40, subtract 40, be negative 2, so x is negative 1. Now I have 2 of the variables, and I have the original problems that have 3 variables in them. So I can take those, z and x, and go back to an original now to solve. Okay, so that's what we want to do. We want to take those 2 and go to an original problem and plug in. So we're going back up to one of the originals. Doesn't matter which one. Pick one and work it out. I'm going to pick the second one. 5 times -1 plus y plus 2 times, we're not 5 times, yeah, and then 2 times z is 4. Plug that in there. Found x and z, so I replaced x and z in one of the originals. Okay, so step 4 that we're doing here is substitute. You got to substitute back to get your other variables. Okay, so that's -5 plus y plus 8 equals 10. So that'd be y plus 3 equals 10. So y is 7. How did we write our answers with systems of equations? With two variable systems as an ordered pair. So with the 3 variables, we're going to write an ordered triple. It's always x, y, z, or if they use different letters, it's in alphabetical order is how it's normally done there. So this would be -1, 7, 4. No, we're not nearly as excited about it as first block was. Saddens me. Maybe you'll get excited about it. Okay. So a little bit longer, a couple extra steps there, but skill-wise, it's the same stuff we've been doing. Okay, not anything really new about that. Let's look at this one. Let's do number 2. 4x plus y minus 3z is equal to 45. And then the second equation is 6x minus 4y plus 3z equals 41. And the last equation is 2x minus 7y minus 11z is equal to 85. So, 3 variable system. Our first step, what was the step 1?
Pick 2 out.
Pick 2 out and pick what? A variable to get rid of. And it doesn't matter which one you pick to get rid of. One's going to be probably easier than the others, but it should end up giving you the same answer at the end if you do everything correctly. So for this one, what variable do we want to try to eliminate? Y would work good. Would X work okay on this one? Yeah, I could take the first one and the third one and change the third one to like a -4 pretty easily, right? And then I could take the second and the third one and get rid of the 6 with the -3 times the last one. So both of these, either eliminating y or eliminating x, would work well for this one. It doesn't matter. Pick your choice and go with that. So I'm going to eliminate x just to do something different besides eliminating y, because we did that on the first one. So I'm going to eliminate x. So I'm going to take first and third together. So equation 1 and equation 3. I'm going to eliminate x with those. So to do that, and this is where you kind of start doing some of the steps in your head a little bit, the first one's not going to change. But to eliminate, what do I have to do to the third one? I've got to multiply by -2. So I'm just going to go ahead and do that multiplication. That'd be -4x plus 14y plus 22z. And then I got to do 85 times -2. So that'd be -170. And then I put those two together. The x's go away. And then 45 from 170 would be 120, -125. Is that right? All right, so that was using 1 and 3. That's the pair that I used there. And eliminated x. If you want to do the same things that I'm doing, I'm eliminating x first. If you're choosing to eliminate another variable, then we'll see you at the end and see if you end up with the same thing we did. You should, if you do everything correct. Yeah.
I'm at negative 3z plus positive 21.
It should be a positive 19. That's right. Sorry. Positive 19. Thank you. Any other mistakes up there? Is that what was causing you some distress there? Okay. Call me on it because I get in a hurry sometimes. All right. So we got a positive 19 z and then a 15y. So now we need to take another pair and get rid of the x. So I can either use 1 and 2 or 2 and 3 are my options. I'm going to use 2 and 3 because that saves me from having to multiply both of them by something. So 2 and 3, if I multiply the third one by what to eliminate x? Negative 3. 2 and 3. I'm going to take number 2 is the same. 6x minus 4y plus 3z is equal to 41. And then I'm multiplying the third one by negative 3 this time. So that's going to give me negative 6x, positive 21y, positive 33z, and 3 times 85 would be 255 negative. Is that right? Check me with the calculator there. 3 times 85, 255. This is yes, this is no. Guys, you can talk to me. It's okay. I know I don't do the raise your hand to answer questions thing. I don't like doing that. If I need to start calling on people, I will. So is 3 times 85, 255?
Yes.
Yes, thank you. All right. X's go away. 21y, negative 4y is how much? 17y plus how many z's? 36 this time. And then 41 and negative 255. Negative 214. 14. Okay. Now what? All right, so I'm going to take these two equations that have two variables and put them together as a system and try to do something to get rid of one of those variables. All right, do we know anything in common between 15 and 17 or 19 and 36? No. Should you? Probably not. So what can you do to do elimination on this? Multiply by each other, but make one of them negative. Okay? I'm going to get rid of the y's because that's smaller than 36 and 19. It works the same if you do the 36 and 19. So I'm going to multiply the bottom one by negative 15 and the top one by positive 17. And that's going to give me some numbers there. So 15 times 17, 255. 17 times 19. 255y plus 323z. And then 125 times 17. 2125. Negative. I know this is negative 255. 36 times negative 15. negative 540. Bless you. And then 214 times 15. 214 times 15. 3210. Positive because it's negative times a negative. Put those together. Y's go away. So 3210 minus 2125, 1085. And then negative 540 plus how much? 323. Negative 217. All right, and then we're going to divide those. Negative 5. So we finally have one of our answers. So it took 1, 2, technically 3 steps to get there.
I think you,
Did I mess up?
I think you multiplied the wrong, sum on the last one.
We're at the 3210.
Yeah.
Is that incorrect?
15, or
Negative 15. No, there's 214 times 15. There's 125 times 17. That's right. All right, so Z is negative 5. How do I get Y? Plug it into one of those problems. They don't look like either one of them's real friendly, so I'm just going to pick the top one there. So 15Y plus 19 times negative 5 is equal to negative 125. 15Y minus 50 and 45 being 95. All right. Yes. So add 95. That'd be negative 30. So Y is negative 2. So whether you plugged into the one I plugged into or the other one, you still should get Y is equal to negative 2. Out of that. And then how do I get X? Go back to an original. I'm just going to go to the top one, 4X plus negative 2 minus 3 times negative 5 equals 45. I'm just working that out. 4X, 15 minus 2 would be negative or positive 13. Subtract 13, be 32. Divide by 4. X is 8. Order triple, 8, negative 2, negative 5. About a half page apiece, as far as that, how much work it takes. But if you'll follow those steps one by one, it really isn't that bad. It just takes some time to get there. Let's look at the word problems. See if we can apply this. Once we set it up, then we apply this method to the word problem. So that sheet I handed out there, pull it out. Let's look at number 6 at that problem. That set of problems there. So number 6 is what we're going to start with. Bless you. All right. Snapshot of that. All right. Selling 3 different kinds of tickets: general admission, senior citizen, and child. So the first sentence defines all our variables for us. We want to call general admission X, senior citizens Y, and child Z, that's fine. Or if you want to use A, B, and C, or whatever letters you want to use, it doesn't matter there. I'm gonna use X as general, Y is senior, and Z is child. Okay, that's what I'm using. Okay. Now, let's see if we can set up the three equations that we should have for these three variables. So, first sentence talks about Mark. He bought 9 general admission, 2 senior citizen, and 3 child tickets, and paid $170. What's the equation that goes down for Mark? Easy stuff. Second sentence, Sarah, what's her equation? 5x for general admission, 4y for senior citizens, plus 7z for the kids. And Sarah spent 173. Okay, Kyle is 4x plus y plus 6z, 116.50. So there's our setup on that word problem. It's not too bad. It's actually pretty straightforward on that one. Now let's see if we can solve that thing. So, say that again. Solve for y. Eliminate y with the top two, with the first two equations. So Luke says take those two together and eliminate y. So if I'm going to do that, what operation do I have to do? Multiply which one by something? Top one by -2. So when I do that, that's going to be negative 18x minus 4y minus 6z, bless you, equals -2 times 170 be -340. And then the second one, it doesn't need to change. It's 5x plus 4y plus 7z equal to 173. Put those together. The y's are eliminated. Negative 13x plus z is equal to negative 167. Is that right? Okay, so Luke had a good first step. So what should our second step be? Second. Okay, you can do the first and the third or the second and third. It technically does not matter. I think I want to do first and third because then I only have to multiply by 2 instead of 4. It just keeps my numbers smaller. Okay, so if I do first and third, I'll have 9x plus 2y plus 3z is equal to 170. And then I multiply the third one by -2, so that'd be negative 8x minus 2y minus 12z is equal to 116.50 times 2, 233. Is that right? Yeah, be a negative. Yeah, negative 233. Thank you. Negative 233 there. Now, when I add those two together, works out pretty nice here. You get the y's canceling. You get x minus 9z is equal to how much? Negative 63. All right. Now we have a system. The two green equations there are a 2-variable system. Okay. So this one is one of those where it doesn't really matter which method. It's about the same amount of work if you do elimination or substitution. Doesn't really matter. Pick one. I'm gonna do substitution just to change it up. Okay, I'm gonna solve this problem for x by adding 9z, and I'd have x equals 9z minus 63. And then I'm gonna take that, and the way you do substitution is you take whatever x is equal to and do what with it? Plug it in for x in the other problem. So we got negative 13 times 9z minus 63 plus z is equal to negative 167. Okay. Excuse me. And then distribute negative 9 times 13, negative 13 times 9 to be negative, how much? 117z. Negative 13 times negative 63 will be a positive something. How much? 78. Oh. 13 times 63. 819. 819er. Plus z is equal to negative 167. Simplify a little bit there. We got negative 116z. And then I would move the 819 over. So negative 167 minus 819er. Negative 986. Divide by negative 116. 8.5. Does that make sense in the context of this problem? $8.50. Does that seem like something that would happen at a movie theater? You're not going to get a perfect dollar amount. That makes sense out of that. If we were talking about counting chairs, would 8.5 make sense? No, because you can't have half a chair that's in a room, right? So in the context of the problem, your first answer, when it's a word problem, you want to think, does it make sense in context of the problem? 850, since we're talking about price, does make sense for this kind of problem. So now we know it makes sense, so we're going to proceed to find the other variables. This is where what I did with substitution can help me out here, because I know z, I've got an equation over there that says x equals. All I got to do is plug into that, and I get x. So x is equal to 9 times 850 minus 63, whatever that is, 9 times 850 minus 63. Type that in, 1350. So general admission price to the movie theater, $13.50. That makes sense. That's probably about par for the course in a lot of places. Okay, so how do I find the senior citizen price? Plug both of those in to one of the originals. Doesn't matter which one. I'm going to go for the top one, that 9x. 9 times 1350 plus 2y plus 3 times 850. It's been so Mark's equation is the one I'm using. So I know I'm going to put 9 times 1350 plus 3 times 850. 147. So 2y plus 147 is equal to 170. So that's just simplifying all that work there. Subtract the 147. And we get 20. Hold on. What did I do? 170. 23. That ain't right. Did I mistype something there? 1350 and 8. What did I do wrong? Tell me what I did wrong. I know what it is. X, I put 9. Am I good? 23. Ah, and it's, oh yeah, and that ends up being 1150, doesn't it? That's okay. All right, sorry. Psych myself out. All right, so it's a word problem, so we've got to answer it like a word problem. Not ordered triple here because we're not dealing with just regular problems. We're going to answer it with the question that it asks. It asks, find the cost of each type of ticket. So we just need to list out the cost of each ticket. So general admission was how much? $13.50. Senior $11.50, and child $8.50. That's right. Sweeney, is it okay? Just long. They're long. And there's no question they're long, but they're not bad. We got to do number 7. It's a coin problem. I like the coin problems. They're fun. So number 7, it says Jamie has a collection of 78 nickels, dimes, and quarters that are worth $12.40. That one short statement gives me 2 different equations. What are those 2 equations? All right, nickels plus dimes plus quarters equals 78. That's one of them. Good job. So N plus D plus Q is equal to 78 because that's how many coins we have. N plus D plus Q. And it says that collection of coins is worth $12.40. So Will, go ahead. Good job. All right, now we can go to the next sentence. It says if the number of quarters is doubled, the value becomes 22.15. So I know the 22.15 goes over here. What about the left-hand side? What changes? It's similar to equation 2. Will, go ahead. Since you got us equation 2. Go for it. Yes, because that doubles the quarters amount, right? Yeah, absolutely. So everything else, do we have the N and the D in there as well? I got no's and yeses. Why and why not? Leave the rest the same because we still have nickels and dimes, right? Because that's in the problem. And this will be 0.5 Q. So we got decimals in there because it's money. But can any of our answers be decimals?
Yeah. No, you can't.
Yes, I can start with this.
No, because it's how
In the context of the problem, now regular math, Will's right. Regular math problem, if it was just I gave you a system and it had decimals in it, you could get decimals as answers. But in the context of this word problem, can the answers be decimals?
No.
Yeah, you can't have part of a nickel. You can't have part of a quarter. They don't break them in half and do that way. So it's counting how many nickels, how many dimes, how many quarters. That's whole things. So it doesn't make sense. If we get a decimal or a fraction as an answer here, it doesn't make sense, right? Because we're dealing with counting up a number of coins, and coins don't count as a third of a coin or something like that. So we can't get decimals as answers on this one. We just got to work with them to get the answers. So let's try to solve this. Take me through it. And do what? Okay. So if I take these 2 together and multiply one of those by -1, it'll cancel out what? Ooh, that's nice. That's a pretty good idea. Let's try that. I'm going to multiply the second one by -1, and that's going to give me -0.05 N minus 0.1 dimes minus 0.25 quarters equals negative 12.4. And then the other equation stays the same. And when I add those two together, that takes out the nickels, takes out the dimes, and leaves me 0.25Q is equal to how much? $22.15 minus $12.40. So much? $9.75. How many quarters are in $9.75?
Wait, you don't take away the 0.5?
It's positive 0.5 and a negative 0.25. 0.5 is bigger than 0.25. So, Caitlin, how much you say it was? 39 quarters. Uh-oh. Where do I plug that back in? I don't have an equation that only has two variables in it anymore. What can I do? And do what? Okay. So Caitlin says we could take two different problems and solve for a different variable. Eliminate a different variable, maybe. That might be a good idea, Barrett.
Plug it in, different problem, and solve those there.
Yes, that would work as well. If we, Barrett said, if we take how many quarters we have and we plug it into a couple of these, that'll eliminate one of the variables as well. Just the same as if we took equation 1 and 2 and eliminated nickels or dimes. Either way, it would work just as well. But since we already have an answer, we can take 39 and plug it in for Q in two of these problems, and that will create a system that only has two variables in it. So this is kind of a shortcut. When this happens, we can take a little bit of a shortcut to it. And and if I do that, I'm going to pick equations 1 and 2. And I could solve that one for, get the n and the d by themselves there. So subtract 39. And that'd be n plus d equals 78 minus 39 is how much? 39 again. All right. And then I would take the second equation. And I work that out, I get 0.05 n plus 0.1 dimes. And then I know 25 times 39 is 975, and I subtract that from 1240. So 1240 minus 975, 265 is what that's equal to. And now this system right here is the one I can solve. If I can solve that for one of the other variables, then I can get everything I need. So what method do you want to use to solve that? Yeah, substitution works great. Elimination works great as well. If I use elimination and multiply by negative 0.1, that'll get rid of the dimes. Point one times 39, 3.9. And then this is 0.05n plus 0.1 dimes, 265. When I add those two together, the dimes cancel out, and I get a negative 0.05n. I need negative 3.9 plus 2.65, $1.25, negative 125, divide by 0.05, or negative 0.05. 25 nickels. How many coins total do I have? 78 is what I'm supposed to have. So I got 25 nickels and 39 quarters. So I just need to take 78 minus 39 and then minus 25. That means I have 40 or 14 dimes. 25 nickels, 14 dimes, 39 quarters. So sometimes some things happen that can give us a little bit of a shortcut on this. Still a good bit of work on it, but it's not quite as daunting when you get that happening. It doesn't always happen, but it can happen from time to time. Let's look at number 9 together there on the back. 3 medals are earned in the Olympics: gold, silver, and bronze, if you didn't know. Okay, pretty general knowledge. Gold, silver, and bronze medals in the Olympics. In 2014, those Winter Olympics, the United States earned 28 total medals. So what's our first equation? Yeah. Whatever letters you want to use, if you want to use gold plus silver plus bronze is equal to 28, or X, Y, and Z, it doesn't matter. I'm going to use gold, silver, and bronze out of that. And then the next sentence says there were 2 more gold medals than silver medals. And the number of bronze medals was 4 less than the sum of the gold and silver medals. Oh, me. So that sounds different than what we've been seeing. So let's take that one. There were 2 more gold medals than silver medals. What would an equation for that be? Two more than what? 2 more gold than silver. So silver is going to, gold is going to be silver plus 2, right? And then the next statement says about the bronze medals, it was 4 less than the sum of the gold and silver. So bronze was 4 less than the sum of the number of gold and silver. What? So G plus S, or S plus G, doesn't matter what order, minus 4. The sum of the gold and silver, 4 less than that would be minus 4 from there. Okay, those are weird looking equations. They don't look like the ones we've had. I'm nervous. What do I do?
Yeah.
Say it again. I can plug in G to the third problem. If I do that, I'm using substitution there. If I plug in G to the third problem, that would give me bronze is equal to S plus 2 plus S minus 4. And that simplifies to be 2S minus 2. So that gives us bronze as a form of silver. But what could I do now? Plug what in the top? Okay, both the bronze and the gold is what she's saying. We could take this and replace gold in the first equation. We could take this and replace bronze in the first equation. So a little bit different plan of attack on this one, but it was because our equations were much different than what we've been dealing with. Okay, so if we do that, S plus 2 replaces gold, plus the S that was there to begin with, and then the bronze was 2S minus 2, and that equals 28. Now we've got an equation that only has one kind of variable in it. So we simplify the 4S is equal to 28, because the 2's cancel each other out, right? And the silver medals was 7, which means the gold medals was 9, which means the bronze medals, the 2 times 7 minus 2 would be 12. Does 12, 9, and 7 add up to be 28? Yes, so that must be right. So 9 gold, 7 silver, 12 bronze. Setting up these equations is key, and then using some I guess logical sense to get there. All right, so you only got 5 problems on the practice for this. Tomorrow, the quiz does not cover this. This will not be on the quiz. Okay? The quiz will cover like systems of equations by graphing, by substitution, by elimination, and the word problems are those. There are 3 word problems on the quiz. No, they're not. You don't have to finish those. We just did some of the examples there. There are 2 word problems on the practice for homework 6. 3 regular systems there. So that's our plan for the next step.